Hi, my name is Zach Daughtry. I'm doing this presentation for Team 1, and our product is On Again, Off Again. During the second design phase, we were kind of able to expand on our original design of an automatic light switch and create a functional decomposition diagram. We did a gallery method walkabout during our class, and we also made a concept combination table with possible solutions at the bottom, and did a concept screening and selection process to kind of narrow down our options for right now. Right here is our gallery method poster. These little sticky notes on it are comments from other kids in the class that kind of help us shape and mold our product into something that we think we can turn into our final product. These other two components, this is a DC motor, which is a major piece of our product, and this is a mock-up kit, which is what we think it's going to look like, something like what it's going to look like when you receive the product after you purchase it. During the first design phase, we decided that we were going to make a light switch attachment that you put on your light switch, and it will turn the light switch on or off from anywhere in the room that you are, using either Bluetooth, or we'll have a wired connection where you just press a button and it'll transmit that to the Arduino, which is also part of our product, and it will alert the crank or box to flip the light switch on or off. We were able to make a mission statement with those preliminary ideas that we had. We also made a customer needs and customer profile. We were also able to make kind of preliminary specifications for what we think that we wanted to do. So this is kind of a broken down, a very, very basic chart for how we think that our product will work. It's called the black box method. So basically you have stored energy, which would be a battery or an outlet in this case, and you would flip on an on or off switch, and it would alert the motor to turn on using mechanical energy, and then turn the light switch on or off. So this functional decomposition diagram is a little more complicated than the black box method. So you have your stored energy, which is the battery. When it receives input from the on or off switch, it converts that stored energy to mechanical energy, which would turn the motor on or off depending on what you needed at the time. So this is our concept combination table. We had a bunch of different sub-functions. So we had our part that actually turned the light switch on or off. We had our power, and then we had our functionality to use it from across the room. So we thought of a wheel idea that would flip the light switch on or off. We also thought of a box idea, which would either lower or raise to turn it off. And we thought of a trolley, which would move across the light switch, flip the light switch on or off, and then move back. We also had outlet power, we had battery powered, and we had solar powered. Our third sub-function, we thought of a Bluetooth app that could work. We also thought we could use a remote, and then we thought of a wired connection where you would just have to put it in one place and click the button on or off. We combined a few that we thought would pair the best together, and we created a few possible solutions down here. Our number one solution right now is the arm or the wheel paired with a battery, paired with a remote. We think that that's going to be the most cost effective and also the most ergonomic for the student. Another method we thought would work is the box method paired with the battery, which would be a wired connection. So we think that the box method would be used really well. It would apply a great amount of downward force, so that flipping the light switch on or off would be a problem, and it allows for easy manual switching if you just were walking by and wanted to flip the light switch. We used a 635 brainstorming technique to come up with a bunch of ideas that we thought might work with our product. So obviously we have a lightweight remote, we wanted to prevent energy runoff, and we wanted to have a box that would move up or down. We also had some ideas that would work with different types of light switches. It could come with multiple command strips for easy access to the wall. Like if you wanted to move it, you could just peel the command strip you're using, move it to another space, put another command strip on, and you're done. And we also had the idea that the trolley would move back and forth to flip the light switch on or off. So we took a lot of when we did the gallery method during class, we got a lot of great feedback from students. They have a lot of great ideas, and we decided to kind of rank the most important ones in order from 1 to 5. So 1 being the most important, 5 being the least important. The feedback that we thought was the most important was that there should be a few different mounting options. So our plan was to use a command strip to mount it on the wall. That way to prevent wall damage, and it would be easily portable. Some people didn't like that idea, and they thought maybe there should be other options. So we took that into heavy consideration, and we're still kind of trying to figure out what we're going to do with that. Another comment we thought was important was that people thought the battery would be the best option. That way, you don't have to do it near an outlet. You can do it on a light switch that's anywhere in your house where you live. We also got another good comment. It should be compatible with multiple types of light switches, and we understand that that's very important to some people, as most houses have different light switches, and we're currently in development of working on something that would work for both. But we are really trying to just make it work with a normal light switch for right now, and possibly later on move on to different types. So this is the screening process that we use to determine which solution would meet the most customer needs. So we had a bunch of different criteria right here, and we would either put a plus if it met that criteria, a 0 if it didn't have anything to do with that criteria, or a minus if it hindered that. So as you can see, solution number 1, which was the wheel or arm paired with the battery, paired with the remote, met the most criteria. So right now that option is in the lead. Our solution number 5, which was solar powered with wired connection and the box method, we thought was the worst idea on our concept combination table. So we decided that after it got a negative score, we just decided to rule it out altogether. So we had to score our different solutions based on a weight that we gave them for what we believed was the most important criteria. And we decided that solution 1, which was the arm or wheel, the battery, the remote method, was the best method as it scored the highest during this process. We understand that the wheel, battery, Bluetooth method works well. However, it would delay our process a lot if we were to have to create an app that would work from your phone with the product. So we're trying to get this out as fast as we can, but also we want to make it as high quality as we can. So we figured the remote would be the best option. Another one that scored really high was the trolley with an outlet and Bluetooth. The trolley ideally is our best option. However, the way to make that is very complicated, and we will definitely not meet our deadline if we try to do that. So I think we are going to go with the wheel, battery, remote method as it scored our highest score, and also it is plausible as something we could actually do. Yeah, so we believe that the wheel, battery, remote is the best option. Here's a little diagram. So you'll have your battery with your Arduino attached to the wall. It will turn this little crank, which will turn the arm to turn it on or off, depending on what your needs are. We also have it so where you can have a remote, which will have enough range to where you could do it from anywhere in the room that you are. We're going to move forward with this idea because we believe it's the best. We'll definitely be able to meet our deadline, and it's very cost effective as it costs about $10 to make, and we're looking to sell it for about $20. And that's the end of our presentation.